So, if you're building with today's most exciting AI, you know the feeling, right? You've got this awesome demo, it works great, but getting it to work reliably out there in the real world, whoa, that is a totally different ballgame. So, how do you actually bridge that gap? Let's get into it. Okay, you're working with RAG, you're building these incredible AI agents, and you've got something that looks absolutely amazing. But let's be honest, is it just a cool demo, or is it a robust, reliable, production-ready system? That's the million-dollar question, isn't it? The secret to crossing that chasm from that cool demo to a real product, it all comes down to one word, ops. And in the world of AI, there are two critical types you absolutely have to know. The classic, MLOps, and its newer cousin, LLMOps. Let's break them down. All right, first things first. We gotta understand the foundation, and that is MLOps. This is the established, battle-tested discipline that really laid all the groundwork for how we manage machine learning in production today. So what even is MLOps? Well, it stands for Machine Learning Operations. But honestly, the best way to get your head around it is with this killer analogy. MLOps is basically DevOps for machine learning. It's all the practices and tools that take a model you've trained and make it actually work reliably in the real world. I mean, just look at the difference here. Without MLOps, it's total chaos. You've got models degrading over time, no versioning, no way to fix things. But with MLOps, you have a system of control. You can monitor performance, roll back to a version that worked, and even automate retraining. It is literally the difference between flying blind and having a full control panel right in front of you. See, MLOps brings this structured, repeatable life cycle to the table. You start with your data, you train, you test, you deploy. Simple enough. But here's the magic. The crucial part is what comes next. Continuous monitoring that feeds back into retraining. It's this closed loop that makes sure your model stays sharp in a world that's always changing. To make this super concrete, think about a bank's loan prediction model. People's borrowing habits change, right? The economy shifts. MLOps is the system that's constantly watching, noticing when the model's predictions start to drift, and then triggering an alert so it can be retrained on new data. It's what makes the system trustworthy and auditable for the long haul. Okay, so MLOps sounds pretty solid, right? So why in the world do we need something new? And that question brings us right to the next big evolution in AI operations, the rise of LLMOps. And this really is the key question. MLOps seems to cover all the bases, doesn't it? It handles the whole life cycle. So why did the industry all of a sudden need to invent this whole new term, LLMOps, just for our modern AI systems? Well, the answer is in the fundamental nature of the models themselves. Traditional machine learning, it's deterministic. You put the same input in, you get the same output out, every time. But LLMs, they're probabilistic. They're driven by the tiny nuances of language and context, which makes their behavior way less predictable. The old rulebook just wasn't built for this kind of fuzziness. This quote right here just nails the difference. If MLOps manages models, LLMOps manages intelligence. Just let that sink in for a second. We've shifted from managing a predictable component to managing a complex, dynamic system that actually reasons and generates. That changes everything. Yeah, managing intelligence introduces a whole new universe of things to worry about. Suddenly, it's not just about data pipelines anymore. Now you're thinking about versioning your prompts, managing vector databases for RAG, keeping an eye on token costs, making sure things are safe, and tackling the huge challenge of hallucination detection. Okay, enough theory. Let's get practical. Let's look at where these two disciplines actually show up in real-world systems and how they work together. So here's a super simple rule of thumb for MLOps. If the main job of your system is to predict something, a number, a category, a probability, then you are squarely in the world of MLOps. And we see this everywhere, right? In finance, it's for fraud detection models. In e-commerce, it's what powers those product recommendation engines. And in manufacturing, it's behind the systems that predict when a machine is about to fail. It is all about prediction. But the moment your AI starts to talk, to reason, or to search and truly understand complex documents, well, you've just crossed over into the LLOps domain. This is for systems that are generating language and insights, not just spitting out numbers. And these are exactly the kinds of systems that so many of you are probably building right now. You've got enterprise search systems powered by RAG, AI-driven customer support bots, and of course, the complex multi-step reasoning of AI agents. All of these require the specialized toolkit of LLMOps to work well. But here's the real pro tip. When you look at enterprise-grade AI, it's rarely one or the other. The most powerful, most sophisticated systems, they don't choose. They combine them, creating a pipeline that gets the best of both worlds. So let's go back to that loan processing system. A big LLM might kick things off by reading a customer's documents and extracting key info. That's pure LLMOps. Then, that clean, structured data gets fed into a classic ML model to calculate a risk score. Boom, that's MLOps. And to finish it off, another LLM call explains the final decision in plain English. And we're back to LLMOps. You see, they work together as a team. So, after all that, how do you decide which ops you actually need for your project? Let's distill all of this down to a single, simple, actionable takeaway. It really all comes down to this one question. You just have to ask yourself, is the core job of my system to predict numbers, like risk or churn? Or is it to generate intelligence, like answering questions, summarizing text, or reasoning through a problem? Your answer points you directly to what you need. And this final comparison is basically your cheat sheet. On one side, MLOps. It trains models to predict numbers, and it manages stable, predictable behavior. On the other, LLOps. It controls intelligence to generate language, and it has to manage probabilistic, less predictable behavior. It's the difference between a calculator and a conversationalist. So look, if you remember just one thing from all this, make it this simple rule. If you're deploying a model, you need MLOps. If you're deploying an AI assistant, you need LLMOps. It's really that clear. Now, the only question is, which one are you building next?